first experiment, we used two D batteries that were 1.5 volts each, and then we used two copper wires and one solenoid made out of a thick copper wire, as well as a really powerful neodymium magnet. So as you can see, once the magnet was placed in a certain way in front of the solenoid, what would happen when it was powered is it would start spinning really quickly. This happens because current traveling through a wire is going to create a magnetic field, and when wrapped around in the shape of a solenoid, the solenoid basically becomes a magnet with the shape of the magnetic field. And if the north and south poles are directly opposed between the magnet and the solenoid, it's going to have the maximum torque on the magnets. Now, if you were to switch the orientation of the magnet, it would actually get pulled by the solenoid, and that's just because the solenoid has the current going through it in such a way that it creates a magnetic field, where the north pole is going to be on the right side as oriented by the black wire, and the south pole is going to be where the red wire is. Therefore, one side is going to attract and one is going to repulse either north or south. For our next project, we created a simple motor in which we have a battery on top of a magnet with a wire going connecting from the top to the bottom, and what will happen is when it's let go, it is going to spin at a fairly fast speed until it eventually falls off because it's not really held in place that well. This happens because a magnet on the bottom of the battery is going to create a magnetic field going upwards throughout the battery and curling out. And then it is also going to be crossed with the current, which is going either to the left or the right, depending on what side of the wire you're looking at. And when the magnetic field and the current are crossed, it creates a magnetic force. And this is done through the right-hand rule too. And that's basically going to cause the wire to spin in the way that you see.